This is lesson 9.2, and before we start that, we're just going to look at reducing some radicals or doing some work with some radicals because we're going to need that for today's lesson. So here, if I have a square root of 7 divided by a square root of 7, those cancel. Anytime we have a root over a root, we can divide those numbers. This is really like the square root of 1, which is 1, and 9 times 1 is just 9. Here, the 2 is not in a square root, so I'm going to reduce the 8 in the 2. I can't touch the 5 because it is in a root. So this would be 8 divided by 2 is 4. Now we could keep the root 5. For number 3, this is our trickiest one. There's something called rationalizing the denominator. We're not allowed to have a square root in the denominator of a fraction. So the real process is we would multiply both the numerator and denominator by the radical that was on the bottom. So root 2 times root 2 is just 2, and then it would become like number 2 where I reduce. The sneaky shortcut that I use in our class is I take 20 divided by the 2 and it becomes 10 and bring the square root of 2 to the top. So 10 square root of 2. For number 4, these are both square roots, so I can actually multiply them. 6 times 7 is really 42. And then I would try to reduce this if I could, but there's no perfect squares that are a factor of 42, so that's as far as it goes. I would leave it there. And for number 5, I can multiply the square root of 3 by the square root of 3, so that's really 2 by just a regular 3, which will give me 6 as an answer. So we're going to look at this picture, which is an isosceles right triangle. I know it's isosceles because these sides are congruent, which would make both of these angles 45 degrees. I could fill that in if I'd like. That also means if it's isosceles, then x would automatically be 1. And I can do the Pythagorean theorem to find y because it's a right triangle and I know 2 of the sides. So y squared equals 1 squared plus 1 squared. So y squared equals 1 plus 1 or 2. And if I take the square root of it, y is equal to the square root of 2. What that meant is I had 2 sides that were exactly the same, and this last side was 1 times the square root of 2. So we had 1, 1, and 1 root 2 as my 3 sides. If this had started out as 2, it would have been 2, 2, and 2 root 2. If this started out as 3, it would have been 3, 3, and 3 root 2, 4, 4, and 4 root 2. So it's always going to be 2 legs that are the same, and then the hypotenuse will equal the leg times the square root of 2. So for a 45, 45, 90 triangle, which is what we're going to call this because it's made up of 2 45-degree angles, and the last one is 90, the hypotenuse will equal the leg times the square root of 2. And I'm going to write it as h equals L root 2. That's going to be the formula that I use for every single 45, 45, 90 triangle. Part A, it's a 45, 45, 90 because I see a 45 and a 90. So these 2 legs would both be 8. I'm going to label my sides with the L's and the H. I'm going to set up h equals L root 2, and I'm going to plug in. For h, I'm going to put in x. For L, I'm going to put in 8. And now I just have to decide, am I done? Is x alone? Are there any like terms left on the other side? The answer to both of those questions, x is alone, no like terms left, so we're done. X is just 8 root 2. For the next one, these are my 2 sides. It's isosceles because they're both x, which tells me it's a 45, 45, 90. So again, I'm going to label. I'm going to write out my formula. I'm going to do this every time. I'm going to put h in as 5 root 2, and x is going to go in for L. In this case, x is not alone, so I'm not done. I'm going to divide both sides by the square root of 2. So the square root of 2's cancel there, but the square root of 2's also cancel there. So x equals 5. For the third one, it's isosceles because those sides are both 5 root 2, so it's a 45, 45, 90. So we're going to set up h equals L root 2. X is going to go in for h. 5 root 2 is going to go in for L, and we have another root 2. So the root 2 times the root 2 is really a regular 2. So 5 times 2 is 10. For this last one, I see the 45 degrees, so this is a 45, 45, 90. So we're going to set up h equals L root 2. So 9 is going to go in for h, and x is going to go in for L. X is not alone. We're going to divide both sides by the square root of 2. They canceled here, but they don't cancel here. So this is where we're going to have to do our little sneaky business. I'm going to divide 9 by a regular 2. Doesn't go in evenly, so I'll leave it as 9 halves. And then I'm going to bring the square root of 2 up to the top where the 9 is. So x is really 9 root 2 over 2, or 4.5 root 2. Either answer is perfectly fine. So you're going to try these two. Pause if you'd like. Answers are posted online. The other type of triangle we have here, this is starting out as an equiangular equilateral triangle. In that case, it was 60, 60, and together this up here was 60, which means each of those pieces was 30. If this little piece was 1 and these parts are congruent, that's also 1, which means each side is really 2. And if it's equilateral and equiangular, these sides are also 2. So already I know that y equals 2. Now I can focus on a right triangle to find x, because this is a right triangle here. I know the 2, I know the 1, I don't know the x. So that's going to be 2 squared equals x squared plus 1 squared. So 4 equals x squared plus 1, 3 equals x squared, x is the square root of 3. So we have 1, 1 root 3, and 2 are the three sides. If I had started with a 2 here, it would have been 2, 2 root 3, and 4. If I started with a 3, it'd be 3, 3 root 3, and 6. 4, 4 root 3, and 8. 5, 5 root 3, and 10. So these two are always 1 times the other, right? Or 1 doubled. Sorry, not 1 times the other. 1 doubled gives me 2, 2 doubled gave me 4, 3 doubled gave me 6. And the second number is always the first number with a root 3, right? 1 and 1 root 3, 2 and 2 root 3, and so on. So now we have rules for the 30, 60, 90 triangle. Notice this one I labeled with uppercase letters because I just wanted to differentiate it from our 45, 45, 90. And we have two formulas because there's 3 variables now. The long leg is equal to the short leg times the square root of 3, and the hypotenuse is equal to 2 times the short leg. I will again write them out in letters. L equals S root 3, and H equals 2S. The long leg is always across from the 60-degree angle, and the short leg is always across from the 30-degree angle. I have some mnemonics to help us remember these two. I don't have anything for our first one, but we can leave the state on root 3. And I don't know about you, but I am always happy to sleep. So we can leave the state on root 3 with L equals S root 3, and I'm always happy to sleep with H equals 2S. So for example 2, we want to find the value of the variables, leave answers as reduced radicals. So I see my 30 degrees here, which means across from that is my short leg. That would make this the 60-degree angle. Across from that is the long leg, and this is my hypotenuse. I'm given S. I have to start with a formula that includes S in it, but luckily for us, both of our formulas included S in it. So if I started with L equals S root 3, I could substitute X in for L, 9 in for S. X is alone, no like terms on this side, so I'm done with that one. But now I have to use the other formula as well, happy to sleep, because there's 2 variables I'm solving for. So I'm going to plug in y for the h, and then 2 times 9 is our s. Y is alone, but there's some work to be done here. So y is really 18. For the next one, here's our 30, so that's the short leg. Here's our 60, so that's the long leg. In this case, I'm looking for the L. I have to use the formula that uses the L. I cannot use h equals 2s because there's nothing to plug in for h. So L equals S root 3. We're going to say x equals root 3 root 3. X is alone, but there are common terms over here, and root 3 times root 3 is just a regular old 3. For C, Here's my 30. Across from 30 is the short side. This was my hypotenuse. That's my long side. So in this case, I'm given h. So I have to start with the formula that includes h in it. I cannot start with L equals S root 3. So if I start with h equals 2s, I'm going to put 12 root 3 in for h and y in for s. So I'm going to divide both sides by 2. So 12 divided by 2 is 6. I'm not going to touch the 3 because it was in a square root. So there's my y. And I'm actually going to put it onto this picture because now when I set up L equals S root 3, x will go in for L, but now 6 root 3 will go in for the short side. X is alone, but root 3 and root 3 can be combined to become regular 3, and 6 times regular 3 is 18. And for my last one here, this 30 means across from it is the short side, across from 60 is the long, and across from the hypotenuse is across from our right angles our hypotenuse. I'm given L, so I'm going to start with the L formula. So 9 equals x root 3, make it a little bigger. I'm going to divide by root 3, and we're going to do our sneaky business. So we're going to divide 9 by the 3 and get 3, and then bring the square root of 3 up to the top. So x would be 3 root 3. And now I could use happy to sleep. So y goes in for h. I just got 3 root 3 for my short side. I can only multiply the like parts. So I can multiply the 2 by the regular 3 to get 6, but I can't touch the square root of 3. So that's state. So here are some problems for you to try. And the answers are posted online, but that is it for this lesson on 9.2.